Alright guys, welcome back. Today we're going to be combining 5-3 parts 1 and 2 together. They're very simple lessons, and I think that putting them together is going to be a lot easier than breaking them up into two different sections. The wonderful thing about this is, after today, after you learn the real slope-intercept method of graphing, you will never have to make a table again to graph a linear equation. You may have to make a table to graph a quadratic or an absolute value or a cubic, but a linear, you will never have to make another table after today, which is great. Another good thing about it, you're going to use this slope-intercept form, I promise, for the rest of your mathematical career. You're going to see it in geometry, you're going to see it in algebra 2 and trig, you're going to see it in pre-calculus, you're going to see it in calculus. So no matter what math you go to, you're going to need this forever. So it would behoove you to really learn it and understand it right now. So let's talk. A linear equation or function, okay, is an equation where x has a power of 1. Please remember, my friends, that when you have a variable like x, please remember that it's being multiplied by a 1. Why? What's 1 times x? X. It's being divided by a 1. Why? What's x divided by 1? X. And it has a power, an invisible power of 1. Why? What's x to the first power? So whenever you have an x or a y or any variable or any number, whenever you have any variable or any number, gentlemen, it is always being multiplied, divided, and raised to a power of 1. So if I see this, y equals 2x plus 3, that's linear. Y equals negative 3/5 x minus 2. That's linear. But if I see y equals x squared minus 5, no, not linear. Okay? So that's the first thing. The power of x always has to be a 1. Second thing, if x has a power different than 1, okay, other than 1, then it is not linear. A linear equation or function produces a straight line. If you are graphing a linear equation or function and your line is not straight, then you made an error. Please, my friends, this doesn't mean that you should beat yourself up. Just be aware of what's going on. For example, if you're graphing, whatever, y equals 2x plus 3, and you get a graph that looks like this, you messed up. You messed up. It's no big deal. You're human. But if you see that, you got to say to yourself, whoa, I did this wrong. I'm going to have to do this again. Okay? Because that's going to be a straight line. A linear equation will always be straight. So if you ever have any curves or angles, anything like that, that is not linear. Linear has to be straight throughout. Does that make sense so far? Okay, now, let's go a little bit back in time. There are two methods for graphing linear equations. And we already know the first method because we did it all quarter. Okay, well, not all quarter, but all of chapter 4. It was by making a table. Remember, you have a dependent and an independent variables. The independent variables can be anything it wants. So, your table method. Simply create an x and y table and choose values for x, the independent variable. Then evaluate the function for the values of x that you have chosen. Use the moral 5. Negative 2, negative 1, 0, 1, and 2. This is the last example we're ever going to use a table for, guys, okay? The last example. When x is negative 2, y is negative 9. When x is negative 1, y is negative 7. When x is 0, y is negative 5. When x is 1, y is negative 3. When x is 2, y is negative 1. So I go ahead and plot these points. Negative 2, negative 9. Negative 1, negative 7. Oh. Negative 1, negative 7. 0, negative 5. 1, negative 3. 2, negative 1. And I have graphed my equation. I have the graph on both sides, the positive side and the negative side, and I'm done. That's easy, right? That's old school. That's old timer stuff. We already did this for last chapter. Does that make sense to everybody? Okay, that is the table method. Now, give me 1 second. Okay, guys, so that's the last time you're going to ever have to use a table. Now we're going to learn the slope-intercept method. And the slope-intercept method, we're going to use the formula y equals mx plus b. Y is the dependent variable. Dependent. M is the slope. That's the rise over run if it's positive, or the fall over run if it's negative. The x is the independent variable, and the b is the y-intercept. The y-intercept is the y value on the y-axis when x equals 0. So what I mean by that is this, gentlemen. Say that my graph goes like this through here. Isn't it intersecting the y-axis right here at this point? What is the ordered pair of that point? 0, 2. That's the y-intercept. That's the y value when x is 0. So that's what I mean by y-intercept. Yes, sir. Who said to add anything? How can you add x and a number? It's an equation. It's a format. We've been talking about this format forever. Y is the independent variable. M is the slope. It's rise over run if it's positive, fall over run if it's negative. X is the independent variable. It could be anything it wants. And B is the y-intercept. The y value on the y-axis, not the x-axis. Y value on the y-axis when x equals 0. So here's how it works. First things first, you got to solve the equation for y. In other words, you want to get the y all alone. You want to solve for y equals mx plus b. Number 2, identify and graph the y-intercept. That's the 0b. That's the b value. 3, from the y-intercept, follow the slope for 3 to 5 points going both forwards and backwards. All of you guys have done this before. Every single one of you. So this should be just a refresher. And as always, let's teach it the right way. Y equals 3x plus 1. They want you to graph each of these. Please notice this in red. You run to the right always, unless going backwards. I don't care if the slope is positive or negative. You always run to the right. You always run to the right. You always run to the right, unless going backwards. And I'm going to show you what that means right now. So step 1, solve for y. We already solved for y. Step 2, what is the y-intercept here? 1. So I go here to 0, 1. Does everyone see how I got that y-intercept?
Yes.
Hello? Okay. Now, what's my slope? 3 over 1. Remember, there's a little imaginary 1 there, right? So from this y-intercept, I'm going to go up 1, 2, 3, and run 1 to the right. Then go up 1, 2, 3, run 1 to the right. Now let's go backwards. Go down from the y-intercept, go down 1, 2, 3, 1 to the left. Down 1, 2, 3, 1 to the left. And you have your graph. No more tables. Bye-bye. So again, I'm going to trace this out now in green. You first graph your y-intercept. And you follow your slope. In this case, it's 3 over 1. So I'm going up 1, 2, 3. So I went up 3, and I went 1 to the right. Then I went up 1, 2, 3, 1 to the right. Then I went up 1, 2, 3, 1 to the right. Then I'm going to go backwards. So backwards, I reverse this. I go down 1, 2, 3, 1 to the left. Go down 1, 2, 3, go 1 to the left. Does that make sense, my brothers? Yes, sir.
Go up or down as many times as
You want 3 to 5 points. 3 to 5 points. So I went 2 above the y-intercept and 2 below the y-intercept. That's 1, 2, 3, 4, 5 points in total. Yes, no, maybe, kind of, sort of?
Yes.
Okay. Next one. I've got 5x minus y equals negative 3. What's the first thing I got to do here, gentlemen? Y alone. Very good. How do I do that, sir? Subtract 5x to both sides. Fantastic. Well done, son. Good job in remembering. So I got negative y equals negative 5x minus 3. How do I solve for y? You divide negative 1 to both sides. Now remember, this is the reverse of distributive property. This is division distributive. This negative 1 has to get divided to this and to this. Remember we talked about that when we were talking about distributive property. So in the end, this is going to equal y equals 5x plus 3. What's my y-intercept? 3. So I go 1, 2, 3. What's my slope? So I go up 1, 2, 3, 4, 5. Run 1 to the right. Look at my graph. It's ending. So let's just go backwards now. Down 1, 2, 3, 4, 5. 1 to the left. Remember, you start from your y-intercept, and then when you're going backwards, you go back to your y-intercept, and you go backwards from there. Sir, what? Don't you understand? What was the y-intercept here, Papa? What's the y-intercept here? Papa, with all due respect, that's why you don't understand it, because you're not paying attention. Y equals mx plus b. What is the y-intercept, the m or the b? So what's the y-intercept here? 3. 1, 2, 3. What don't you understand about that being your y-intercept? No, my y-intercept is 3, right? Okay. What's my slope, sir? Pay attention. What's my slope? 5 over 1, correct? So from my y-intercept, I'm going to go up 1, 2, 3, 4, 5. Run 1 to the right. And then go backwards. Down 1, 2, 3, 4, 5. You're going backwards. 1, 2, 3, 4, 5. 1 to the left. Very simple. Thank you for your honesty. Does that make sense, sir?
Yes.
My brother, does that make sense? Thank you, sir. May I continue? All right, let's continue. Y equals, whoa, negative 0.2. Whoa, what? What's that? How do we convert that to a fraction? How do we convert 0.2 to a fraction? Because we need a fraction as a slope, not a decimal or a mixed number. Right, 0.2 is 2/10, isn't it, guys?
Yes.
Which is 1/5. So this is y equals negative 1/5 x plus 3. Is everyone with me so far? Please pay attention. Is everyone with me so far? Okay, what's the y-intercept here, boys? Okay, so check it out. You go up 1, 2, 3, that's my y-intercept. Now please, stop writing for 1 second and just look up here. What's the slope? Negative 1 over 5. So I'm going to go down 1, and I'm going to run to the right. 1, 2, 3, 4, 5. And to go backwards, I go back to the y-intercept, and to go backwards, I would go up 1, and then 1, 2, 3, 4, 5 to the left. Does that make sense, guys? Why? Why? Why is it say? Why are you guys telling me no? What's the y-intercept? 3. What is the slope, son? Negative 1 over 5. Isn't that a fall over run? Down 1 over 1, 2, 3, 4, 5. Now let's go backwards. Up 1. And then 1, 2, 3, 4, 5 to the left. Thank you for your honesty. What don't you understand? Because you have to go backwards. You have to have the positive side of the equation and the negative side. What else, bro? Thank you for your honesty. Oh, yes, sir. Okay, I thought you had a question. Next, do we have to solve for y for number 2? No, we're done there, right? Easy. So what's my y-intercept? Not 2. Negative 2. So I go down here to negative 2. What's my slope, my brothers? So I'm going to go up 1, 2, 3, and then I'm going to run, very good, son, to the right. 1, 2, 3, 4, 5. Again, up 1, 2, 3, over 1, 2, 3, 4, 5 to the right. Now let's go backwards. So you go back to your y-intercept and you go down 1, 2, 3 over 1, 2, 3, 4, 5. When you connect the dots, it's all a beautiful straight line. Thank you for all the honesty so far. Questions? We're not done. We still got some more examples, but questions so far? I see a lot of people doing the graphs. Thank you. That's gonna be how you learn this. Yes, sir. You sure? Okay. Going once, twice. Sold for $1. All right. All right, now let's see who's got their thinking caps on. Who remembers? What is the equation of y equals 4 going to look like? Oh, what does it look like, Papa? No. Sorry, Baba. Wrong. Wrong one. No, sorry, wrong. It's a horizontal line, guys. Isn't this saying that the line is going through 4 forever? 1, 2, 3, 4. So it's going through here forever. Remember, this is your x-axis, that's your y-axis. This is y equals 4. It never touches x. What's the slope of this line? 0. Remember we talked about that when you saw this line, that was the equation? Okay. What about x equals -5? That's going to be vertical going through 1, 2, 3, 4, -5. So, and the slope is undefined, yes, sir. And the y equals 4, the slope is 0. X equals -5, the slope is undefined, yes, sirs. Very good. That makes sense, boys? Okay. Next. What's the y-intercept here for number 1, please? Okay, 5. So I'm going to graph my y-intercept at 5. 1, 2, 3, 4, 5. What is my slope, my brothers? So that means I'm going to go down 2, and I'm going to run to the right. So I go down 1, 2 over 1, 2, 3. Do it again. Down 1, 2 over 1, 2, 3. Now let's go backwards. So I go back to my y-intercept, and I go up 1, 2 over 1, 2, 3 to the left. Up 1, 2 over 1, 2, 3 to the left. I've got my 5 points. Remember, I need 3 to 5 points. Ding dong, the witch is gone. Does that make sense, gentlemen? You promise? Okay, now, this one I really want you to pay attention for, number 2. I've got 3y plus 5x equals -12. This is only going to mess you up if you're not very strong with equation skills. If you're strong with equation skills, it's a joke. Go for it, my brother. That's exactly the right way to start. You subtract 5x to both sides. I'm very proud of you, son. Good job. So 3y equals -5x minus 12. Okay, here's the tricky part, Papa. What do we do? You divide 3 to both sides. So then y will equal? No. Thank you. And that's a great mistake. I'm proud of that mistake. You'll see now. Thank you very much. Awesome. Look, guys, I had said this before earlier in today's lecture. Please, thank you for remembering, my brother. Please remember that this must be divided to the -5x and to the -12. So this is going to be y equals -5/3 x minus 4. Do you see that, gentlemen? This is what gets everyone on the quizzes and tests. This is what kills you guys. So again, I'm taking my time. We got plenty of time. There's no rush. Does that make sense? Okay. What's the y-intercept here, please? -4. 1, 2, 3, -4. What is my slope, please? Who? -5/3. Very good. X is not part of the slope. Remember that. So that means I'm going to go down. I'm going to go down 5 because it's -5/3. So down 1, 2, 3, 4, 5. And I'm going to run to the right. 1, 2, 3. Do I run to the right even if it's a negative slope? Yes. Now let's go backwards. So how would I go backwards? Up 1, 2, 3, 4, 5, and then 1, 2, 3 to the left. Boom. You're done. 3 to 5 points. Does that make sense, my friends? Promise? Okay. Last skill. This is taking the equation and graphing it, right? Now I'm going to show you guys how to look at a graph and get the equation. For example, number 1 here. This is so easy if you remember the, hold on, Papa. If you remember the following. Y equals mx plus b. You were very eager. Go for it. Okay, wow, he gave it to me. He says, Mr. Morrow, the answer is y equals 3 over 4x plus 3, and he's exactly right. And I'm going to show you why he's exactly right. First off, what is this right here called? The y-intercept. What is the value of the y-intercept there? 3. So that's how I got my 3. You guys with me? Now, from here, what's the other perfect point? I see a perfect point right here. Do you guys see that? So I went up 1, 2, 3 over 1, 2, 3, 4. Isn't that my slope? Y equals 3/4 x plus 3. Does that make sense? And you know that it had to be positive because I'm going up from left to right. Does that make sense? Okay, next one. What about this blue line? What would the equation of that blue line be? Yes, sir. No, the slope is undefined. What is the equation of this? X equals negative 6. 1, 2, 3, 4, 5, 6, negative, yes. X equals negative 6. Very good. If I ask for the slope, sir, the slope is undefined. Yes, it is. Okay. How about this one? This other blue line here. What's this equation going to be? Yes, sir. Yes, sir. No. This is y equals negative 5 because I'm only going to the y-axis. I'm never touching the x, okay? When I go straight through the x-axis, it's an x equals equation, and that's an undefined slope. When I'm going through the y-axis and I never touch x, that's a y equals equation, and that's a 0 slope. Okay, here, what do I got this? What do I have here for this green one? What you got, Papa? Y equals negative 3. You mean x, or just minus 3? How did he get, that's wrong though. It's completely wrong. What's the y-intercept here, guys? So that's 1, 2, 3, 4, 5, 6, 7, 8, negative 9. So that's my y-intercept. My slope. A perfect point is, well, this is a perfect point right here. Down 1, 2, 3 over 1. So negative 3x minus 9. So you had the slope, my brother, you just messed up with the intercept. Does that make, no thank you. Does that make sense, my brothers? You promise? All right, awesome. I think we are done with the lesson. All right, awesome. Great job.